In question 4, we're asked to solve the system of linear equations 2x plus 3y equals 6 and 2x plus y equals negative 2. Since we already have our x terms lined up or stacked on top of each other, our y terms stacked on top of each other, our equal signs stacked on top of each other, and our constants stacked on top of each other, we're going to use the elimination method, which could also be referred to as the addition method. And we're going to cancel out one of the variables in order to find the value of the other variable. Since we already have 2x and 2x, I'm going to be using that. I'm going to choose to cancel x. And in order to do that, I would need to have a negative 2x in one of these equations. So what I'm going to do is multiply the entire second equation by negative 1. I'm going to bring down my first equation as is. And now my second equation, everything is multiplied by negative 1. Distribute the negative 1 to all terms. And you're going to end up with a negative 2x minus y equals a negative 2, which is a positive 2. After doing that, you can combine or add. That's why it's called the addition method. Eliminate one variable, so we eliminated x now, and we're adding the rest. 2x minus 2x cancels out. 3y minus y is 2y. Equal sign comes down, add the 6 and the 2 to get 8. And then you would have to divide by 2 to get y alone. Y is equal to 4. However, we want the solution, which is the point of intersection of those two linear equations. So we also need to know what the x value is. In order to find the x value, you could use either of the two original equations. I'm going to use the second one. So I'm going to use 2x plus y equals negative 2 in order to find the x value. I know that y is equal to 4. Wherever I see y, I'm going to plug in a 4. Substitute that. And then I'm going to solve for x. Subtract from 4 from both sides. 2x is equal to a negative 6. In order to get x alone, you divide by 2. X is going to be equal to a negative 3. X is equal to negative 3 and y is equal to 4, making our solution negative 3, 4. That's the ordered pair. Question 5. In question 5, we're given a family is traveling from their home to a relative's house. A table of values shows their distance from home as a function of time. The time is given in hours and the distance is given in miles. After traveling 0 hours, they're 0 miles. That's their starting point. It makes sense. They didn't travel any hours yet, so they didn't move any distance. However, after 1 hour, they are 70 miles. 3 hours later, 118 miles. 6 hours later, they're at 216 miles, and 9 hours later, they're at 324 miles. If we want to find the average rate of change between hours 3 and 9, we're going to focus in on this column and this column. And to find the rate of change, we're going to have to take the change in the output, which is the change in distance. And that would be 324 minus 118, and divide that change by the change in time. Which would be 9 minus 3. The numerator is going to work out to be 206, and this is divided by 6. And then you're going to get 34.3, which I'm going to round to be 34. And that would be miles per hour. You must put the unit. So on average, they're traveling 34 miles per hour. However, that doesn't mean that everything is consistent. That's the average. Because if you're looking here, they went 70 miles an hour here, and then they slowed their rate over here. So they are going to drive a little faster some hours and then a little slower, but on average it would be 34. That's the average rate of change, miles per hour. In question 6, this is an exponential growth situation. Adrian invested $2,000 into an account. The account earns 3.5 interest rate compounded yearly. She made no deposits or withdrawals within that year for 4 years. We would like to write the equation and determine to the nearest dollar how much the account has after 4 years. So when you have an exponential growth situation, the formula would be capital A is equal to P times 1 plus R. We're adding on the interest rate each year. Raise that to the T power, which is the time in years. So we're going to find our new amount A by taking our principal amount, or our initial amount. That was the initial investment of $2,000. We're going to multiply that by 1 plus the rate. They told us that it was 3.5% interest rate, annual interest rate. However, we have to express that our value is a decimal, so we're going to take 3.5%. In order to make that a decimal, move the decimal point 2 places to the left. The rate, therefore, is going to be 0.035. That's what you add on to 1. And you raise it to the T power. So that would be the equation in general. However, they told us T in years, and they told us that they're interested in 4 years later. So I'm going to take that equation and plug in 4 for T. On your calculator, 2,000 parentheses 1 plus the rate is a decimal, make sure it's a decimal, 0.035, and raise that to the 4th power, which is going to come out to be a new amount